All right, solving word problems, an introduction. So before we do some actual problems, let's go over the steps. The first thing you want to do is read the problem and identify the important information. And also you want to identify the unimportant information and ignore it. And you're probably wondering, why would they put information you don't need in the problem? Well, one of the things that you're learning to do is identifying what you need and what you don't need. And then when things are more complicated, you'll want to organize the information. Sometimes you'll use a chart. All right. The next step, a lot of people skip, but you should never skip this step. And that is name the variable. And the reason why is if you haven't explicitly named it, you might set up an equation and not know exactly what your equation means. So it's very important to name your variable. You're going to write your equation and then solve it. And then another very important step is check your answer. So write it out and ask yourself, does the answer make sense? So if your variable represented the number of chickens and your answer turns out to be -5, does that make sense? If you said no, you would be correct because there's no such thing as -5 chickens. All right, let's do some actual problems. All right, let's take a look. The length of a rectangle is 5 centimeters more than the width. If the perimeter is 38 centimeters, find the length and the width. All right, so eventually you'll do problems with more than one variable. For right now, we're just using one. But you'll notice we're looking to find two quantities. So you'll need to decide which one is going to be your variable. Will it be the length or the width? So one thing that can help you is when you're given a relationship between the two quantities, it can help you decide which one to call x. So if we look at the first sentence, the length of a rectangle is 5 centimeters more than the width. So we have a relationship between the length and the width. And what you might notice here is that we're using the width to describe the length. So the one that's used in the description should be x. So we're using which in the description. If you said width, you would be correct. And why do we do that? Because now we can use this description to write the other variable. So can you write an expression for the length? So you'll basically translate this into an algebraic expression. And if you want to hit the pause button, this would be a good time. All right, so if you wrote x plus 5 for the length, you would be correct. All right, what is our problem telling us? The perimeter is 38 centimeters. So sometimes it helps to draw a picture. And you'll recall that the perimeter is the distance around an object. So you're basically adding up the width and the length, and then the length and the width. and that's equal to 38. So 38 is the length plus the length plus the width plus the width, or the sum of all four sides. But let's rewrite it in terms of x. And again, if you want to hit the pause button and try that. So the length is x plus 5. And then we add the length again. And then the width. And then the width again. And let's solve it. So all of the x are on the same side. So we add x and x and x and x. And we get 4x. 5 plus 5 is 10. This is a linear equation, so we want to isolate x. We can subtract 10 from both sides. And then divide both sides by 4. And you might think we're done, but you always want to go back and reread the original problem and ask if you're done. And also ask yourself, does this answer make sense? So you'll go back and you'll remember that we're looking for the length and the width. We named x the width, so that means that 7 is our width. And then go back and check. And remember, we were talking in terms of centimeters, so be sure and put those units on your answer. And then to find the length, we look at what the definition of the length is. So that's whatever the width is plus 5. So 7 plus 5 is the length. 7 plus 5 is 12. And then always give the units. And then ask yourself if those numbers sound right. So if we have a rectangle that's 7 centimeters by 12 centimeters, is the perimeter in fact 38? Well, 7 plus 12 plus 7 plus 12 in fact makes 38. All right, let's do another. All right, a truck rental company charges $30 per day and 5 cents per mile. If your one-day rental cost $33.60, how many miles did you drive? All right, so what are we looking for? We're looking for the number of miles. So let's call that X. All right. So what does the cost consist of? Well, we have this fixed cost. They charge you $30 for the day, no matter what. And then 5 cents per mile. Well, this is the part of the cost that varies with the number of miles. So we call that the variable cost. Well, the fixed cost is just $30. So what's the variable cost? Well, that's 5 cents per mile. Well, we're using 30, that's dollars. So if we have 5 cents and we want to write that as dollars, we should move the decimal point. So if you drove 1 mile, they charge you 5 cents. If you drove 2 miles, it'll be 5 cents times 2, or 10 cents. If you drive 3 miles, that's 5 cents times 3, or 15 cents. So to calculate the cost per mile, you're going to multiply 0.05 times the number of miles, and that's the variable cost, the part of the cost that varies. And then our total cost was $33.60. And again, if you want to try solving this on your own, I would hit the pause button. All right, let's check your answer. So we have x on one side. So we want to isolate x because this is a linear equation. So we'll subtract 30 from both sides. And then we'll divide both sides by the coefficient of x. So we'll divide both sides by 0.05. So this is equal to 1. 3.60 divided by 0.05 is 72. You want to go back and read your original problem. What does x represent? That's the number of miles. All right, let's try another. All right, Tan is selling tickets to an orchestra concert. The cheap tickets are $10 and the expensive tickets are $15. They sold a total of $700 worth of tickets, and they sold twice as many of the cheap tickets. How many of each did they sell? So again, we're looking for two quantities, the number of cheap tickets and the number of expensive tickets. So I would hit the pause button and decide which one is going to be x, and then write an expression for the other. All right. So one way you can think of it as we're going to be multiplying one of them by 2 because there's twice as many. So which one gets multiplied by 2? There's twice as many of the cheap tickets So the smaller quantity is the number of expensive tickets. So we call X the number of expensive tickets, and then they sold twice as many of the cheap tickets. So that's the number of cheap tickets. All right, so they made $10 each from the cheap tickets and $15 per ticket from the number of expensive tickets. And then again, if you want to hit pause and set up that equation, this would be a good time. So the total amount of money they made from selling expensive tickets is 15 times the number of tickets. And then the amount of money they made from selling cheap tickets is 10 times the number of cheap tickets. So that's 10 times 2x. And then the total amount of money is $700. And then again, if you want to try solving that on your own. All right, so the first thing we need to do is simplify each side. So 10 times 2x is 20x. Both x's are on the same side, so we want to combine like terms. And then in order to isolate x, we'll divide both sides by the coefficient of x, which is 35. Over 35 equals 1. 700 divided by 35 is 20. And then you want to go back and look at the description of your variable. And now we know that they sold 20 expensive tickets. How many cheap tickets did they sell? We'll use this expression, 2 times x. Well, if x is 20, that's 2 times 20. So they sold 40 of the cheap tickets. All right, this one's extra challenging. Let me show you why. All right, Fran works at a store for $15 per hour and also walks dogs for $20 per hour. Last week, she worked a total of 40 hours and earned a total of $690. How many hours did she work at each? So in this one, we're not given a relationship between the two quantities. We're looking for the number of hours working at the store and the number of hours walking dogs. And normally there'd be a statement like, she walked dogs 5 more hours or worked at the store 3 times as long. All we know is this total. All right, when you have something like this, name one of them X. So let's call X number of hours worked at the store. All right, I'm going to make a little table. because sometimes when you really get stuck, just throw in some numbers and see what happens. So let's just do some what ifs. What if she only worked 5 hours at the store? How many hours did she walk the dog? Or dogs. So she worked a total of 40 hours. If 5 of them were at the store, how many hours were walking dogs? If you said 35, that would be correct. Now, how did you get 35? That's right, you took 40 and subtracted 5 from it. All right, what if she only worked 7 hours at the store? How many hours did she walk dogs? All right, that would be 33. And where did you get 33? By subtracting the number of hours worked at the store from 40. What if she worked at the store for 12 hours? How many hours would she have walked the dogs? That's right, 28. How did you get 28? What if she worked at the store for 25 hours? How many hours would she have spent walking the dog? That's right. All right, so one of the secrets of math is seeing patterns. I'm going to cover up part of this chart. All right, so when she worked 5 hours at the store, she walked dogs 40 minus 5. If she spent 7 hours at the store, she walked dogs 40 minus 7. Do you see a pattern? If we know the number of hours at the store, in order to find the number of hours walking dogs, we just subtract it from 40. So if the number of hours working at the store is X, what would this be? And I would hit pause and take a moment. Right, so if you follow the pattern, if you know the number of hours working at the store, to find the number of hours walking the dog, it's just going to be 40 minus the number of hours worked at the store. So 40 minus X is the number of hours that she walked the dogs. All right, let's put that all together in an equation. So at the store, she made $15 per hour. So to find the total amount of money she made at the store, that'd be 15 times the number of hours. And then to find the amount of money she made walking dogs, it would be 20 times the number of hours walking the dog. And since this is an expression, you'll want to put parentheses around it. And then that's equal to the total amount of money she earned for the week. And again, if you want to hit pause and try solving that on your own. All right, so the first thing you want to do is distribute And then because the variables are on the same side, you want to combine like terms. So positive 15x and negative 20x make negative 5x. All right, then we'll subtract 800 from both sides. And divide both sides by negative 5. And then go back and reread your original problem. And it asks, how many hours did she work at each job? So we remember that X is the number of hours that she worked at the store. So that would be 22. And then to find the number of hours that she walked the dog, we subtract that from 40 and get 18. All right. So the secret of being good at word problems is just to practice a lot. Take your time and good luck.